Assalamu alaikum warahmatullahi wabarakatuh. My dear students, so you are welcome to today's class. As we all know, our last class was based on the revision for the last time. So where we discussed some topic that we've already laid our hand upon last time. So the next episode of our lesson for today will be that we are going to look at some of the topics that we are going to do in third term. So our first topics. So let me first tell you that the accompanying note with this video, you have your scheme of work. That is some of the topics that we are going to discuss this time. So you have mechanical energy, you have heat and temperature, and then heat at its measurement, and then the rest. So the first topic we are going to look at is the mechanical energy. And under this topic, so we are going to look at work. So we try to know the meaning of work, the parameter that we can use or in which the work based upon. We discuss the types of mechanical energy. We also discuss the principle of conservation of energy. And later in this topic, we are going to look at machines, the meaning of machine, the types of machine, and simple problems that we can encounter under machine. So the first thing we are going to look at here is work. What is work? Don't forget that in LS1 you did work, energy, and power. Work, energy, and power. So it's the same definition that you were given there that we are still going to go by. So work is said to be done whenever a force is being applied or a force moves its point of application through a certain distance. So you must understand that anytime you are talking about work, two things are very, very essential in the definition of work. If these two parameters, if one of it is missing in the explanation of work, sorry, you missed it. So what are those two things? They are the applied force and distance or displacement. That is, for scientists or physicists to accept that a certain person or an object has done work on another object, there must be an application of force, and the body must also cover some certain distance or displacement. So going by that definition, we just use this simple diagram as an illustration. We have a situation in which we have in a body, say an object being stationary. Then there is application of force, which is F here. Now, if this one is applied in order to change the position of this object from here to this point, which means that this object has covered a certain distance, which is S. Please note, this S does not mean speed, it means distance or displacement. Don't forget, when the direction of your distance is specified, we call it displacement. Your distance and displacement is being treated the same way, they have the same units. Now, if the point of application of this force is applied in such a way that is able to change the position of an object from its initial position to new position, which means that such body has covered a certain distance, then work has been done by this force. How do I mean? Let me illustrate this. Let's assume I have a stool before me. A stool. If I apply force on that stool and the stool changes position from initial to new position, that means I'm able to perform work on what? On the stool. So work has been performed. But in the scenario whereby I'm trying to push on the stool, in order to cause a change in position of the stool from initial to new position, and there is no success. How do I mean? That is, I'm trying to push the stool and I'm unable to push it, I'm unable to shift that stool from its initial to new position. It means that I'm only applying the force, but the distance is not there because the stool has not moved an inch. So in that case, I've not performed any work. No work has been done. We consider what being done when a force is applied on the body, causing that body to change in its position or move through a certain distance. So in that case, we say work has been done. Then from that definition of work, though you have the note, the accompanying note with this video, you have the note that you're going to study. So I'm just trying to explain. Now, from the definition of work, you understand that those two things, which is force and distance, make up a formula for work. That is, work equal force times distance. Force times distance. Work, W, equal force times distance. And from here, the unit of work, as we know, the SI unit of work is joules. SI unit of work is joules. Joules. SI unit of work is joules. And its derived unit, the derived unit can be obtained from the definition of work, which is force and distance. And the derived unit is Newton per meter. That is 1 joule equal 1 Newton per meter. This Newton per meter is obtained from the unit of force, which is Newton, and the unit of distance, S, which is meter. Please and please, not Newton per meter, is Newton meter. Sorry for that. Not Newton per meter, is Newton meter, because my force is in Newton and my S is in what? Which is distance, is in meter. So 1 joule equal 1 Newton meter. Now, it's also possible for us or for a force to be applied at a certain angle to the horizontal. How do I mean? Consider a situation in which you have a crate of bottles. You have a crate of bottles, in which you don't want to push to cause that crate to move on the floor. We attach a rope to one end of that crate. Then we are using that rope being attached to the crate to pull that crate in order to cause a change in the position of the crate from initial position to another position. You will see that the rope being attached to that crate of bottles is held at a certain, or is going to be held at a certain angle to the floor being the horizontal. Now consider this second diagram, this second diagram. Take this one as figure 1. Take this as figure 1 and take this as figure 2. Now look at this. You are having an object and the force is being applied at a certain angle theta, to the horizontal, so that we can use this force to pull this object to this point, so as to cause a change of position through this distance S. Now, in this case, what we are going to do is, because the force has also been applied, that's why the crate has been, or the object has been able to move from here to this point. That means the object has covered a certain distance S. So force is applied and the body has covered a certain distance. So work has been done. Now, how do we know the magnitude? How do we know the magnitude of the force? How do we know the magnitude of the work that has been performed? Through the application of this force. Now, what we just need to do is to resolve. Don't forget your resolution of vector or resolution of force is to resolve our F horizontally. Resolve this force with respect to this angle theta horizontally. If you find the horizontal component of this force, you will discover that here we are going to have Fx equal, we are going to have Fx, that is the horizontal component, equal F, this F, cos theta. We are going to have Fx equal F cos theta if we find the horizontal component of this. Now, in this case, our work from definition of work, which is force times distance, I will still have my F cos theta. That is the horizontal component. In fact, I can write it as Fx times S, but the resolution of my Fx here equal F cos theta times S. But I implore you not to be writing this formula this way. Why? Because you might get confused by multiplying this S and this theta before you later take the cosine of it. That's wrong. What you are going to do is to write it this way. That is F times distance, then cos theta. You need to multiply the magnitude before you are given by the distance covered by this body, then multiply by the cosine of the angle of inclination. Angle of inclination of what? Of the force. Then the unit of work done still remain joules. The SI unit still remain joules, or Newton meter, or Newton meter. Now note one thing. Note one thing. The application of the force must be parallel to the distance. That's the only point that can make work to be performed or to be done on another object. If the application of the force is perpendicular to the distance, the work will not be done. The work will not be done. That is, the work being done on that body when the angle of inclination of the force is 90 degrees, that's perpendicular, is 90 degrees to this S, that is distance. Work is zero. How do I mean, or what do I mean? I mean that if you have the distance and you have the force, that is the angle between them is now 90 degrees. In this case, what you are going to have will be work done equal F times distance cos 90. Don't forget, cos 90 will not give you anything other than 0. Cos 90 will not give you anything other than what? 0. Now, whatever the value of force and distance might be, because cos 90 will give you what? 0. So all these values what? Will tend to 0. The other, the work equals 0. So at this point, when the application of force is perpendicular to the distance covered by the body, the work will not be done. So the work is only done when the force is parallel to the what? To the distance covered by the body. So we can also define or redefine our work in terms of energy. Don't forget, work and energy, they are related. They are measured in the same, using the same unit, and they are calculated using the same formula, the force and distance, and they have the same unit, which is joule or Newton meter. Now, work can also be redefined as a measure of the transfer of energy between one body and another body. A measure of the transfer of energy stored in one body and another, or on another body. From this definition, what's the meaning of this definition? From this definition, it means that if I have a stool, let me use that of stool as a perfect example. The energy stored in me will be used or can be transferred to that stool and causing that stool to change its position. That means I'm using the energy stored in me to cause a change in position of the stool, thereby using that energy to perform work on that stool. So that's why we define or redefine work as a measure of the transfer of energy from one body to another body. So let's look at an example. So the question for this example 1, is in your notes that accompany this video. So I will just give you the solution to that example. So listen to the question. A load is pulled 40 meters. A load is pulled 40 meters along the horizontal floor. Along the horizontal floor by a constant force of 6 Newton, which add at an angle theta to the floor. Determine the value of angle theta if the work done by the force is 75 joules. A load is pulled 40 meters along the horizontal floor by a constant force of 6 Newton, which acts at an angle theta to the floor. Determine the value of angle theta if the work done by the force is 75 joules. Now, solution to that is that, according to the question, you can interpret the question as this. You're having a load, this is a load, is pulled 40 meters, that is the distance covered by this S equal 40 meters. So this is the load, by a constant force of 6 Newton, which acts at an angle theta degree. This force acts at angle theta degree to the floor. This is the floor. That is, it acts with respect to the horizontal direction. So this one is 6 Newton. Then we are given theta A. So the question is now asking us to find the value of the theta when the work done equals 75 joules. So what we are given in the equation is that we are given the work, and again we are also given the force, which is 6 Newton. We are given F, which is 40 meters. Then from here we are looking for theta, that is unknown. We are looking for theta, which is unknown. Now, using work done equal. Mind you, we cannot use the first expression, which is work equal force and distance. The reason being that if you check this expression, there is no theta here, so we cannot use it. So the best expression for us to use is using the one that contains theta, which is F times distance cos theta. So I have F times S cos theta. So from here we are going to make our cos theta the subject of formula. So my cos theta equal work done over force times distance. And in this case, I will have my work done is 75, force is 6, and my S is what? 40. Please and please, before you solve anything, make sure that all the parameters are in SI units. SI units. Work is in joules, force is in Newton, and S in 40 meters. Mind you that distance S is in centimeter. Please, you convert it to meter. Then from here, if you find the value of that, then you can find our theta to be. Don't forget, by the time you use your calculator to find this and this, that you now find arc cos this answer. Then our theta will be 71.8 degree. 71.8 degree. Please, you need to put the unit to indicate that you are looking for, or you are finding or solving for the angle, which is what? Which is theta. That's solution to example 1. Now we have mechanical energy. What is mechanical energy? Mechanical energy is the energy that is related, or the energy that a body can be used to perform work. This energy is of two types. You have the notes with you that follow this video. So let me just break it down. We have two types of mechanical energy. We have the kinetic energy, we have the potential energy. The kinetic energy is the energy possessed by virtue of motion of a particular object or particular body. That is, kinetic energy is the energy possessed when the body is in motion, when the body is moving. For instance, a car that is in motion possesses kinetic energy. An athlete that is running possesses kinetic energy. Different object that is in motion, so when they are in motion, they have speed, they have velocity, so they possess kinetic energy. So how do we know that they possess kinetic energy? Now, somebody is running, then encounters another small object. The person that is running encounters small object, then collide with that small object. What is going to happen? Because the person that is running has potential kinetic energy in him, is going to push that small body away from his flow. It means that an energy has been transferred on that small body. That is why such small body is going to what? Is going to is going to collapse. So, and a body that is moving possesses kinetic energy. Why potential energy is the energy possessed by a body that is at rest. My dear student, we've come to the end of today's class. So by the special grace of Almighty Allah, we are going to continue next class. So I want you to go through your notes. You make sure you go through it, and then any problem you encounter, so you can forward the question to me on this number. On this number, you can WhatsApp me on 07065933261, or you email me at salakonajim@gmail.com for any questions. And don't forget, you have assignments in your notes. Make sure you go through it, and one that is giving you problems, so you let me know. Bye for now.